Hello, I hope that you had a good day so far and are ready for Module 3. In this module, we'll talk about analog to digital conversion and digital signals conversion to analog. So the idea is to preserve information when we exchange the signals from one domain to another domain. In this video, we'll discuss the purpose and key concept of analog to digital conversion. Many messages, the source of signals, are inherently digital in nature, like when you type your text message or when you type an email. So the text is digital in nature. But in many applications, this is not true. For instance, your sound signal or video or many other signals like the temperature inside a reactor and so on, when you sense them, the nature of those information are analog, as they are continuous in time and also they are continuous in value. The objective of this module is to make analog messages and signals amenable for processing in digital domain. For these, we need the following theories. The first one is because our messages are continuous in time, so we need to convert the continuous time into discrete time. So we need to take samples from our signals. For instance, from your voice signals, we get a number of samples per second, or if you have a picture, we get a number of samples per image, which produces pixels horizontally and vertically. The number of samples we need to get should be enough in order to be able to reconstruct the original signals. We don't want to lose information, because when we take samples, we are not necessarily taking the whole information. So we want to know some theories behind this. The second concept we need is, once we get these samples, each sample value or each set of sample value, they could have any real value. And a real value needs lots of bits to be represented. So therefore, we will quantize these real values. And the purpose is to represent these samples or symbols with a finite set of number of bits or finite set of alphabets. So using this discrete set of symbols, we may reconstruct the original signals with some distortion. So some amount of information is lost in the second step, while in the sampling stage, we try to be able to have as perfect reconstruction as possible. The last theory is, once we quantize these samples, after quantization step, we need to encode them. We need to map these symbols or these quantized values to a string or a stream of digital signals, typically binary values. It could be symbols to be transmitted or stored or manipulated for next stage.